Intelligent City makes mass timber-based prefabricated systems for urban housing. And specifically, we make the structure, the floor panels and the envelope panels. And we try to integrate as much as possible. So we're not making the material. We're not making mass timber. We're just using mass timber from the market. Just like, a car company buys the steel coils and then makes that into a car or car parts. We take the mass timber, we machine it, and we assemble it into more finished components. The envelope is a pretty good example because you kind of really see it's from the inside wall, which is mass timber and could just remain mass timber, all the way to the cladding and the windows, completely finished. You drop the panels on the building and you're done. And so the value proposition here is that aside from the fact that it's more sustainable and nicer material to work with, it is cost competitive and you're faster. And enclosing your building much faster. You can even build a structure much faster. And it's early days for us. It's we're building our second building right now. And so there are still a lot of challenges we are overcoming, but we can see this. I can tell you just last week, we put a floor up in a day. It was really awesome to see that happening. So when everything clicks together, you can really see the advantages.
Hey everyone, we've got a very cool episode today on the future of building, how mass timber is shifting from concept to real construction sites. Our guest today, Oliver David Krieg, president at Intelligent City. He went from robotics labs in Stuttgart to leading prefab timber housing across North America. In our conversation, OD unpacks how to install a full floor of mass timber in a single day, why it outperforms concrete on safety, carbon, and comfort, and how AI and robotics have already driven precision and quality control. So if you want to see where construction is heading, faster, cleaner, smarter, this episode is for you. Let's dive in. Hey everyone, thanks for listening to another episode of Buildings 2.0. Today I'm with a special guest today, Oliver David Krieg, president at Intelligent Cities. Oliver, thanks for your time.
Hey, it's a pleasure to be here. Thanks so much.
Take us back. So you have a super interesting background from studying architecture to robotics to now mass timber. Before we get into all the fun stuff as to what you're working on today, bringing mass timber to the masses, what made you fall in love with buildings in the first place?
Yeah, that's a really good question. And I think it's a good question for everyone who works in this industry, right? How did you get into the built environment, into love with buildings? For me, there's always been these two different opposites in my own mind. I've always really liked design and art and expression. And I also always liked technology. Started programming when I was 14 and I designed my own websites, but I also learned Photoshop and 3D modeling around that time. And I probably would have gone into engineering, to be honest, if it wasn't for my sister telling me that, hey, you have to choose something that you love, or else you won't be good at it. And so even without any background in architecture, my family hasn't been in architecture at all. I didn't know any architects, to be honest. I just thought that was the right combination of art and design, and also technology and math, and structure. Although, to be fair, little did I know that architecture is actually quite a lot towards design and much less into technology. At least the educational part wasn't. But I really enjoyed it. And to be fair, I would have probably just gone down the typical educational lane of architects who go through school and then, find an office or found their own office. If it hadn't been for a new professor that came up in our university and founded a new institute, the Institute for Computational Design and Construction at the University of Stuttgart in Germany, who just came in swinging with computational design and parametrics and robotics. And he was one of those very early people who heavily were involved with computational design and who understood there is maybe an opportunity to use computers to program a design rather than to draw a design. And maybe we can use machines and innovative manufacturing processes to change what we built. And that's when sort of my technology mind got really interested, and I just went into that direction. And I was probably pretty scared for some time. That was in the early 2000s, that I may go down somewhere where I'm not employable at the end. Don't have buildings in my portfolios. I have weird little
scripts and
exactly, scripts, grasshopper scripts and things like that. But I just went with it. I loved it. It was very enjoyable. It really also sparked my design mind, because a lot of parametric design is about intricacies of design. And so I just went down that road for a very long time, and ultimately ended up doing a PhD in that direction. And that's sort of how I met wood as well as a material. When you play around with these scripts, what I learned, at least then, was it was all about the materialization of your designs, right? How are you going to engage with the material, and how are we going to make it a reality, even if it's just a little structure or some bus shelter or something like that, right? Or a pavilion. What is it made of? Why is it made of that? And it was always this sort of conversation between what the material wants, what you can manufacture, and what the design outcomes can be. So it was bottom up. It was actually the biggest challenge, even after only like 2-3 years of architecture school. The biggest challenge was to completely invert the design process from a top down, I'm the genius who has this, I'm making a line on a piece of paper and this is the building, and, now you go and make it happen, right? That sort of top down approach to a bottom up approach, and saying, I have this material, I have veneer that I can glue together and bend, and like, what's that bending capacity? What can I do with that? Or even the moisture in the veneer, or, anything with plywood. What does the brick want, right? What material want to do? And explore what we could do, and put that into an algorithm, and then play with it in the digital world, come up with some design exploration, and then make that again into a reality. So you kind of close the loop, right? From material to programming back into material. Right. And that was really fascinating to me, especially as a student who kind of learned that.
But kind of guide me through that bridge. So from the academic setting where you were quite literally bending material, asking what it could do, to kind of this next step. I mean, what was that transition like?
Yeah, I think it was also, in a way, parametric design matured over the decades. Definitely started even before the 2000s, right? And it's very explorative, very theoretical. And I think in the early 2000s and 2010s, it was still pretty explorative, but a lot of architecture schools started to, build something, right? They got robots, ETH Zurich, AA London, Michigan. A lot of universities got robots. They put spindles on them to mill things, or grippers to assemble pieces, right? Or, to glue or to nail, or whatever it is. Right. And they explored that, and they built little bus shelters, benches, pavilions with it. And at first, it was very small and was a little bit, I guess, laughed about as well. I think, from other fields, people didn't take it too seriously, because, it wasn't very serious. It was just a sort of base level exploration of what we can do. But it became, obviously, you're building up that expertise, right? You're building up your knowledge about materials, about manufacturing. I was how old? Maybe 23 when I started using an industrial robot. I started programming a robot, and started to understand what the robot can and cannot do. And so you start sort of ingrain that expertise of manufacturing, and you go bigger and bigger as you go along. And so by the time I had graduated and decided that I wanted to stick around and become a researcher and do a PhD in that field, we started building bigger and bigger structures and big shells that were, 30 feet, 50 feet, 100 feet long. And it became, went into construction basically more. And so I did that for about 6 to 8 years, and worked on several research projects where we collaborated with timber companies as well, and builders. So, we had to think about how this actually gets constructed. We had to do structural analysis. So we collaborated with engineers. So you started to really replicate a little bit what a normal construction project is like. But again, I didn't really think about where this could go in the real world. And I keep saying this, by the way. I think I was just lucky. I didn't plan to get into computational design or robotics, and I didn't plan to get into industry either. I just happened to teach a workshop in Vancouver, British Columbia, on robotics. One of the founders of Intelligent City was a participant, because he wanted to know what robots could do for his ideas. And that was in 2017. Afterwards, we talked about what he was trying to do. And he basically told me, listen, I've been working on several buildings in the last 20 years, and I'm trying to sort of he was a very early proponent of what you call the missing middle now. I don't even think it was called the missing middle back then when he worked on it, but he was trying to find different typologies of living, especially in North America. You're kind of stuck between a single family house and a 60-story tower where you live in a shoebox. And they were trying to experiment in sort of 4-story, 6-story, what can you build? And how can it look like? And he said, well, we've done this a couple of times now. It's clear it's very hard to replicate. I want to find a way to replicate and scale this up and build housing and factories, but it has to be customizable enough so that we can build many different buildings, because multifamily has a huge amount of customization from project to project. So how do you marry that need for customization and the potential for scalability so that you can build housing at scale? And that's when it clicked to me, because then I realized, hey, that idea of parametric design and parametric manufacturing, if you will, using robotics and other equipment, that actually can be applied in the real world. And so I got really excited about that and joined the company. And that was 8 years ago. So it took a long time to get to this point, right? It's a very long journey, which is, I think, very atypical for our industry. You can see it wasn't a very natural progression. I think I was just lucky enough to meet the right people at the right time as well.
Mm-hmm. I think one of the underlying themes here is wood, and specifically timber. So for those that may not know, including myself, like I'm a novice, kind of demystify why this particular material matters. Why should we care about it? Perhaps all the kind of, falsehoods about maybe either safety, cost, sustainability. I mean, what should folks know?
Yeah. Well, in the beginning, I was just fascinated by the material because from a designer's perspective, it is a natural material. And so it always brings with it inconsistencies and a grain, right? And a certain surface finish that is just really exciting to work with. And if especially if you combine that sort of irregularity with regular patterns, I just always really enjoyed that. And that's why I back then I founded ODK Design, because I wanted to explore what you can design with that combination of sort of very accurate patterning that comes from machines and the natural material that sort of brings its own pattern. You overlay those two. I still find that very fascinating. But that's how I got into material, and it's very easy to machine and to work with. It's all things considered, probably one of the healthiest materials to work with. It's not completely healthy either. It just is dangerous. We all have to understand that as well, but it's less dangerous than working with steel or concrete or, glass fiber or carbon fiber. So I enjoyed working with the material. When I got into mass timber, which is what Intelligent City is using as the main building material, I realized there's a huge difference to timber. And timber construction, when we talk about that, especially in North America, we think about 2x4s, right? 2x6s, light wood frame construction. And light wood frame construction comes with its own challenges, right? It's a very cheap construction method, and that's why it's been so prevalent. Right? It's basically, you don't need a lot of equipment, you don't need a lot of expertise. Oh, you do need expertise, I apologize, but you don't need a lot of technology to use the material. But of course, a lot of it is experience, right? So if you go on site as a carpenter and you put a low-rise building together, there's a lot of ingrained knowledge of how everything works. And that's why it's very straightforward to use the material. But it's dimensionally not very stable. It can burn very easily because you have a lot of surface area, like all these sticks, right? That's how you build a fire, right? You start with very small sticks, lots of surface area. So it has to be protected at all times. And so if you go to mass timber, it's like now you're at a log size, right? It's glued together. In North America, it's glued together from 2x8s or 2x10s. And it is very solid. And because it's glued together, it is dimensionally stable like plywood and is structurally very well performing. And it is fire safe in the sense that it doesn't actually just burn or go up in flames. It needs a very strong source of fire to start burning, and then it'll just char. And so it basically creates its own insulation layer. That the charring layer insulates the rest of the material. And as a result, it chars in a very predictable manner. And that's been tested now over 30, 40 years. There's a certain rate at which it chars. And so you can actually calculate how much material you need to sacrifice to have the remainder still be stable enough, strong enough for the building not to collapse. So this is always the goal in buildings, right? You need to, when it says you need a 2 hour fire rating. What it means is you need the building to stand for 2 hours so people can escape and the fire can be extinguished. 2 hours in high rise, 1 hour in low rise. So if you need to achieve that, you can. This is why mass timber made its way into high rise construction, because engineers and certifiers were able to say, yes, this material is valid, it's structurally stable, it's resilient for earthquakes. And if there's a fire, especially in residential construction, right, there's a fire in an apartment, the building won't just collapse, it won't go out of control. And so predictability, calculability is very important in that. So it's very different from stick frame construction.
Yeah. In your view, what needs to be true in order for mass timber to truly hit the masses? Meaning, is the ambition, or rather, do you envision that we're going to be building commercial residential buildings with this material, or is the ambition to serve as an alternative? I'm curious, how do you kind of reverse engineer to truly start to see this en masse?
Yeah. We have to acknowledge that it's a new building material. In our industry, a new building material can take 50 to 100 years to really take over, right? You can look back when an iron was invented. Engineers used iron the way they used wood, right? The way they jointed the components, the way even they formed the components was to mirror how wood construction worked, timber construction. And the same with concrete, right? It took a long time, decades, to find the language of the material and to understand what it means for the construction process. And so what I like to tell people now is actually to emphasize that it's different, because it's important to understand that processes on a construction site change when you use mass timber. We shouldn't take it lightly. We shouldn't just say, oh, it's just the same volume. Instead of concrete, it's wood. Like, what's the big deal, right? It is a big deal. A lot of things happen. A lot of things are different. All the connections, a lot of processes, scheduling on site. You have to emphasize different aspects. But that being said, I'm saying it's early days because the material at this point is still more expensive than concrete. And that's sort of usually when you look at cost comparisons, concrete building with mass timber buildings, like every comparison nowadays is sort of plus minus 5%. Like it's not clear to really point at one specific aspect that makes it more expensive or less expensive. You have more time savings. It's a lighter material, so foundations are less costly. Other aspects like that, but then the material is more expensive, and so on. That's more expensive again. But the biggest hurdle is that it's not being used a lot. And the industry takes a long time to adopt a new material. And so there isn't much experience with the material. So I think it has the potential to take over a lot of construction in residential or in commercial, but it's going to take a long time for builders and trades to learn how to use the material. And, if we're talking about a housing crisis and we have to build more housing, we can't just expect that to happen with the current materials and methods and people that we have. We need to become more efficient, and we have fewer people per construction site, so we can have more construction sites, right? And mass timber is a very good way for that. So I can envision that taking over a large portion of construction. I'm not saying that there's just one material, right? Every city, every jurisdiction, they have their own materials. Sometimes some states and some provinces tend to use more steel than concrete. It's the same thing for timber. I can tell you in Canada, we have 3 times more timber or lumber that we can harvest per year sustainably than we would need to build all housing out of mass timber. There is a massive amount of timber available. And if the forests are managed properly, and what I mean with that is don't manage all the forests, focus on which to manage or even plant your own like they do in Europe, manage them sustainably, then you have the material to scale mass timber up significantly.
For those wanting to kind of make a clear break, let's say I am a commercial developer, I'm casually interested in exploring mass timber. Help me kind of draw the line. Like, why should I not choose, for example, perhaps broadly accepted concrete, for example? Like, why not that?
Yeah. So first of all, I would want to clarify that mass timber and prefab are 2 very different things, right? So I can give you some reasons to use mass timber, and I can give you some reasons to go with prefab, which is a completely different story. And mass timber is not prefab, but mass timber can be used in prefab, right? Just like stick frame can be used in prefab, and the whole prefab industry has its own opportunities and challenges. But if you just look to, should I go and build a normal concrete building or should I go and build a mass timber building? If it's cost competitive, the advantages that you will have is that it is, first of all, you probably will be able to build it faster, because even without prefab, mass timber is a little bit faster to build because you have big components that you just put on, right? All the formwork and concrete pouring is taken away, or most of it at least. And then you have a more natural material. You can leave it exposed. You can save on drywall. You can use it on the ceilings or on the walls. It is a biophilic material, which means that it is perceived as more natural and nicer to live in. There have even been studies about that. It kind of balances the climate indoors as well because it absorbs moisture and releases it again. So it's just a nicer climate to live in. And ultimately, it's a much more sustainable material. Even if you don't take the sequestration into account, the CO2 the trees absorb, right? You could always argue, but what happens after the end of life? Are you burning the wood or not? Well, if you take that out of the equation, it's still much, much better in GHG emissions than concrete. Ultimately, it kind of goes towards prefab because it lends itself to prefab. But even without prefab, it's a cleaner site. It's a faster construction, less problems. It's more predictable. But that's because it forces us to plan ahead a little bit more, right? Especially because it's a new material. We plan ahead more. The more we plan, the less problems you have on site. So it's not exactly clear where that comes from, but I can tell you, especially when you look at prefab, well, now you're talking about lots of planning up front, much more rigorous construction site, much faster. And now you unlock these additional benefits.
Are you finding that there's specific geographies, whether North America, Europe, or elsewhere, whereby either regulations, incentives are more aggressively pushing for migration?
Yeah. So in Europe, a lot of people, when you look at prefab especially, talk about the fact that, I think in Germany, they make 40% of single family housing prefabricated. I think in Sweden, it's 80%. And I toured some of the German, Austrian, Switzerland prefab companies a few years ago. What they told me and what I also saw was it's very evident the energy requirements, basically how well insulated your building needs to be and how watertight and airtight it needs to be, are just higher. And when they're higher, you're not using lumber anymore to build your walls because the walls are just too thick for a 2x6 or 2x8. So using larger pieces of timber, and they are then usually engineered timber like glulam or LVL. So they're engineered, now they're bigger, they're more precise and dimensionally stable. So now you can use prefab. And so basically the thinking is, if it's wood, it's prefab, because there is no way in Europe you can build with 2x4s, right? The wood automatically means you're actually talking about engineered timber. And so it just naturally became that. And I think we're pretty close to that, especially in Canada. The energy requirements keep going up, rightfully so. That soon, in the next few years, we'll be at that point where you realize it just doesn't make sense to try to achieve that on site. It makes more sense to achieve that in a factory. But also, it's sort of it's kind of an upward spiral, right? Because once you have more prefab companies and you see more prefab, you also realize, okay, it is better, it is faster. You need a lot of buildings built with a certain prefab method to really make the point and for more broad adoption to take hold. And I understand that a lot of developers are skeptical and conservative about that because there's a lot of money on the line. And builders too, right? They don't have very high margins. And so if they make a mistake, it's very dangerous for them financially. So you need to build proof. And that just takes, 10 years or so.
Yep. Do you just to kind of wrap my head around it, are we talking mostly greenfield, or is there mass timber usage in renovations or retrofits?
There can be. There's two things that I can think of. One is urban densification. If you have an existing structure and you want to put a few more levels on top, mass timber is actually great for that because it is so light. It's about half the weight of concrete, of a concrete structure. It's much lighter, of course, by volume, but you do need a bit more volume in the structure compared to concrete. So you end up at about half the structural weight. So it's easier to put more floors on top of an existing building. And then the other part is Intelligent City makes envelope panels with a mass timber structure. Instead of steel frame, it's mass timber. It's just a different material. And it's essentially a curtain wall system. And so that is a really good idea for retrofit, You take the facade of a building, you scan the edges of the slabs, and then you build your 3D models and you build the panels, you hang them back on the existing structure, and you're done. So Quick can be a very fast way to retrofit, and it's actually something where we think could be a really good market for us as well. We're not looking at it right now, but we keep hearing about that, and that's something we want to look into.
You're president at Intelligent City. You're on the front lines of mass timber and specifically for housing. Walk me a little bit through the business itself. Like what's keeping you busy? What does it mean to be a mass timber building platform, and what's the offering?
Yeah. So in short, Intelligent City makes mass timber-based prefabricated systems for urban housing, and specifically we make the structure, the floor panels, and the envelope panels, and we try to integrate as much as possible. So we're not making the material, we're not making mass timber, we're just using mass timber from the market. Just like, a car company buys the steel coils and then makes that into a car or car parts. We take the mass timber, we machine it, and we assemble it into more finished components. The envelope is a pretty good example because you kind of really see it's from the inside wall, which is mass timber and could just remain mass timber, all the way to the cladding and the windows, completely finished. You drop the panels on the building and you're done. And so the value proposition here is that aside from the fact that it's more sustainable and nicer material to work with, it is cost competitive and you're faster. And enclosing your building much faster, you can even build a structure much faster. And it's early days for us. It's we're building our second building right now, and so there are still a lot of challenges we are overcoming. But we can see this. I can tell you, just last week we put a floor up in a day. It was really awesome to see that happening. So when everything clicks together, you can really see the advantages. And we decided to do that because, like I said in the beginning, the idea for the company was that if you find a way to standardize a lot of the processes, but enable a certain level of customization so you can access a big enough market segment, you have solved prefab problem. The prefab problem is that the idea of prefab has been around for 150 or maybe even 200 years. No prefab company has ever been able to really access be that in offices or commercial or residential in our case. I think hotels are getting pretty close because hotels can be very standardized. And our opinion is that the standardization has always been the problem. In order to solve it, you try to standardize, but then you locked into a certain design and it's hard to replicate that too many times, right? So you need that flexibility.
Right.
And so that's why we thought it has to be a platform, a product platform that is configurable. And we have to ingrain that configurability in our components so we can enable many different buildings.
Tell me a little bit more about that. I mean, so does it quite literally mean that you're working hand in hand with real estate teams, designers, engineers to quite literally form the building from the material?
Yeah. There's a lot still going on and a lot of different paths into the future, I would say. But we basically said that, okay, you have to, be able, the envelope, let's take envelope as an example, as its own sort of standalone product. It has to be able to, accommodate many different geometric situations. It has to go on corners, inside corners, outside corners. It has to have parapets. It has to have balconies. It has to have overhangs, right? Soffits. How do these situations get resolved? A lot of these details can be standardized, which is really great. So you have repetitiveness, right? But then the dimensions of the panels have to be quite flexible because residential buildings are often, different lengths and different grid spaces, and we have to accommodate that. Where the windows sit, what kind of windows, what kind of cladding, that's where you have to have that customization. When you think about product development, well, you have to engineer it and solve it, and then you can offer it, right? And so we're trying to engineer these different solutions with the thinking that, yes, your panel can be longer and shorter and you can have different cladding systems so we can then offer it. And because we can't just do that in a void forever, we have to apply it. We have to see how it works. Prototyping is hard in our industry because you can't build a prototype 50-unit apartment building and then demolish it afterwards. We have to do this collaboratively. We're working with architects, we're working with developers on sort of what flexibility, what level of customization, or what sort of unique design do they want to make their buildings happen. And we take that and we bring that into our product. And over time, we'll have enough configurability to really automate that and really quickly design different buildings for different developers or architects or engineers.
You kind of alluded to this, but how do you envision your go-to-market motion? Are you often being brought into projects through the designers themselves, architects, engineers, or are you actually partnering directly with the owner operators? What's that look like?
Yeah, it's both. And
Mm,
it's evolving as well.
mm,
Because I think there's a lot of education still happening, both in terms of mass timber and prefab. So obviously we have two challenges to overcome. It's oftentimes very good for us to talk to developers directly and show them what's possible. So we do a lot of feasibility studies for developers where we show them this is how your building could look like roughly. This is how a structural system in mass timber looks like. This is how our envelope looks like, and explain to them what's the cost implication, what's the design implication, so that they get on board, because they carry the risk. But then you go down or backwards basically, and we're talking to builders, and we were partnering up with builders, because ultimately we are just a subcontractor to a builder, and we are supplying the components to the builder. We are installing it ourselves, but then it's still part of the general contractor, or the builder responsibility. So they have to understand it. They have to be on board. They have to see the benefits, especially the time savings. And so we have to educate them. And if they know about our system, they can also suggest it in their next project, right? So that's good for us as well. And then it's the same for the architect and the engineer. If they know about our system and they understand how it works, they can also spec it or suggest it to the client. So it's kind of the entire chain of consultants. It's good for all of them to know about us, and the builder and developer as well. And we're seeing sort of 50-50 right now, from architects and engineers, and also from the developers directly. And then once they decide they want to go with us, we build a team. Either the developer builds a team, or we build a team of architects and engineers and all the consultants. And then we just do the design assist along the design process of a building.
One thing that stands out to me, selfishly as a startup founder myself, is deciding to go venture. I think Intelligent Cities decided to raise some capital. It's been a story that real estate and venture tend to have kind of a rocky history, right? Where some of the notable kind of explosions of like the WeWorks or the Terras of the world, where you raise a lot of capital, and then there's this expectation to kind of grow at the scale of, maybe perhaps software would grow. How do you reconcile that? How do you reconcile kind of the financing strategy around growth? Of course, there are expectations there in venture capital, as well as just some of the realities of like there's just buildings and physical stuff that kind of operates in a different timeline. How do
Yeah.
you think through that?
Yeah, that's a great question. And I think that's exactly right. Like how can you combine construction with or real estate with venture capital, right? And I think the answer honestly is you can't properly combine it. I think construction and innovation in the construction industry is very different from what the venture capital world is used to normally. But I will also say, you know, we shouldn't compare ourselves to software startups, to SaaS. We should compare ourselves to manufacturing startups. If you look at a car company as a startup, right? How many decades it takes for a car company to have a profit? That's ultimately the same problem. If you're moving atoms instead of bits, the time scales and the effort that needs to be put into it is just very different. But it's also at the same time very long lasting and has a very long term opportunity here. And especially if you look at how many housing units are actually being built, and how big the market is, and how you as a company that can have an impact on the industry, that it can seep into a very large market very quickly once it's proven. So we learned over time that it is much better to talk to strategics, real estate investors, construction firms that have an investment arm, or companies that are in the industry and have an investment arm, companies or investors that are more interested in manufacturing or agriculture or clean tech, where they know in order to build something, you need a little bit more patience, right? It's not a 3 to 5 year turnaround. It is a bit of a longer phase. And that's what we found made a lot more sense.
To zoom in for a moment, you're at the helm of an incredibly exciting company. What are some of the day-to-day challenges that you're facing right now as you're designing, defining the product itself, working with customers, building out a team, building out what seems to be kind of an A to Z assembly line here? I'm curious, what's keeping you up? Like, what's
A lot of things.
that's
Yeah.
usually what the answer is. Yeah.
Yeah. I think it's very tough to innovate in mass timber, in prefab, and build a company around that at the same time. Like I said, you can't build a prototype building. In our industry, unfortunately, you can't. Like you can blow up 10 rockets and still be a successful space startup. And that's fair. I actually support that. I think, anywhere between what NASA is doing, what SpaceX is doing, that's good. You are investing heavily upfront and you have a, potential huge return, but it requires, potentially billions in investments to get there. I think Rivian raised 14 or 16 billion before they even went into the IPO, and they still have to become profitable. That's very, very hard in our industry. We struggle with that. We can't fully develop our product to that level of sophistication and configurability or customization that we would like to before we go to market. So we're really sort of going right now still from project to project. We're obviously learning a ton. We're drinking through a fire hose, and we're trying to implement that and get to a more refined product. We were able to get into a relatively small factory space, 15,000 square foot facility here in BC. And it's tiny. And obviously we knew when we did this 5 years ago, we knew that we wouldn't be able to make a lot of money in this facility, but we went in anyway because that was what we could get. And we proved out that we can manufacture out of this one. But now we also know we have to scale. So you're constantly strapped for resources. You could do a better job, but that's all we get. And I think, that's the frustration. But at the same time, you take a step back and you look at it and you think, hey, we're building our second building right now. We have even less than 50 people. Half of them are factory staff that are putting these things together. This is really amazing. I'm really, really proud of the team that we have, because you need dedication if you're constantly fighting an uphill battle. So it can be frustrating, but I also think that, we have a real chance at this.
Yeah. It wouldn't be a tech-centric podcast if I didn't ask about AI. And I have to imagine across, the variety of different activities, from sourcing to design to production to manufacturing, we could list off a ton of different things your team has to focus on. But has AI at all impacted the way that you produce and deliver the work?
In aspects maybe that you wouldn't think about if you talk about AI right now. I think you talk about AI right now, you probably think about automation and planning, right? How can you, especially architecture, how can you make architecture production more efficient? And the interesting thing for us is that on the planning side, it's really much more for us about defining the platform or the system correctly. And once we have that, we can build automation on top of that very easily. The challenge is not to automate it. The challenge is to define it properly, right? To define it in enough detail so that you can automatically generate different building design with our system. And we have the advantage that it's very, very constrained compared to, if you talk about Revit, right? Where you can build or design an airport and a museum and a single family house, right? Like where do you even start? For us, it's multifamily. There are certain constraints with, the cladding and the window positions and the setbacks, and that's it, right? And then you have a very well-defined system, and you can automate that very well. I'm very excited about that opportunity, because we know that once we have defined that well enough, it'll be very easy for us to automate the design process way beyond what people expect. Right now, we have a little bit of AI in our factory, because when you work with big elements, big pieces, they're never 100% precise. And so we are using cameras and sensors and lasers to measure what we are assembling while we are assembling it. And the robots automatically react to that and adapt their movements based on the tolerances that we see during the assembly process. And we're taking pictures and a lot of other things automatically, where we are building a quality control database that we can learn from in an AI manner in the future as well. So we have a lot of good data. It's not very dirty. It's not very, chaotic. So we have a very good basis to automate a lot of stuff in the future, but we are still at a very early stage in that regard.
One of the things that you brought up that I think stand out to me, and this is a struggle that I'm sure a lot of designers face, is that the spectrum that you laid out between full customization and like just elements that, could maybe exist as kind of one or two or three different configurations. In that spectrum of just complete customization and curation, what's your hunch as you think about Intelligent City? Is it is you swaying towards like full customization, like needs to be true, some version of there needs to only be a certain amount of kind of cataloged moves? How do you
Mhm.
think about that? Because I think that ties into what ultimately I think is just kind of that scalability factor to, how novel, but also how kind of scalable is the solution.
Yeah. Would you live in an apartment or buy an apartment if you knew that there are five other buildings that are very similar in your city? It's an interesting question. And when you ask it, you actually think about, well, why does it need to be unique for me to like it? Right? Any other products we buy in our lives are standardized. You can do a lot to them, right? You can buy many different laptops, many different brands of laptops, many different sizes of laptops, many different configurations, and you can customize them. We all put stickers on them, and same with our cars. We can customize our cars and buy different rims and tint the windows and
Right.
and things like that to make it more like ours, which is certainly a need that we have, and I totally understand that. But if you look at it on a multifamily high-rise building with 150 units or so, it's a lot about the interiors actually that you live in, that you want high quality, good, healthy materials, right? That's very easy to achieve. And we will have the same level of customization that we have nowadays, at least for the 80-90% of market condos or rentals, right? I'm not talking about the super high end. There will always be super high end. I mean, hell, there's Lamborghini or Ferrari who built their cars more or less by hand anyway, or Bugatti, right? They always exist and it's fine. They're great. But there's also the Audi and Mercedes and Volkswagen that churn out a very high number of cars, and they limit maybe more the customization. And I think we'll end up somewhere in there. Right? But you have to prove that by limiting yourself to some extent, at least, by limiting yourself slightly compared to the status quo in design flexibility, you actually gain quality, right? And you gain a better building that is made in a factory and is much more precise, much more airtight, warmer, right? You don't have to your feet don't get cold when you stand at the windows. Things like that, are a benefit. But again, it has to be proven over time. And I think we are still at a very early stage. So making these arguments right now is more towards the future. But as we build more buildings, I think that will become a general understanding. You kind of see, oh, okay, I'm getting something better for it. So I'm okay slightly constraining myself in terms of what kind of building designs I want as a developer, as an architect.
Indeed, this has been really fun. I think our conversation here is an incredible primer from everything from the market to mass timber to materiality to venture capital to business models. I guess to ask you one final question before we hop here is now having the benefit of hindsight of several years at the front lines of both business and construction, what would you tell the young OD coming out of college that he's learned along the way, being introduced to industry and outside of academia?
Learn more about burn rates and cash flows. I think I went into it. I was quite naive when I went into it, I think. But I mean, we all are, right? And to some extent, maybe that's why I went into it, and I wouldn't have if I hadn't been so naive. So in some ways, I'm also reflecting on the fact that maybe that was beneficial. But I think we suffer as architects or builders, we suffer from the same product market fit traps that other industries or other segments suffer from too, right? We think we have a really great idea. The number one thing you have to do is you have to analyze the market and see what the market wants, or analyze it in a way that you understand what they might not know about that they want. But you have to be very clear about that. Product market fit is really, really important, and also be really truthful to what you can achieve. I think in our industry, especially construction, is really about honesty and building relationships. You can't bullshit your way into a building. There will be so many eyes on you. You really have to say, this is what I can deliver, and then deliver it and talk to the people, right? Because this is a collaborative effort. One single company cannot change this industry. This requires everyone to work together. I think that's a lot of lessons in one sentence, but it's been very important to learn that over time and to adapt our strategy and how we operate.
OD, appreciate your time.
Thank you so much. It's been a pleasure.